We're going to look at the costs now. So I split it up again in this beautiful chart. On the left, you see the categories again: envelope, QC, engineering, testing, and heating, ventilation, and air conditioning. And I'm not going to read this down. This is just a comparison of the baseline building, double hung versus casement, and exhaust only versus balanced air. So there are these differences. And on the very right side, I'm showing the cost differences. So we tallied this up. We did a full estimate of the baseline building, and obviously we have the actual cost of the actual passive house. So 1.2 million on the envelope, similar on quality control and engineering, and 1.8 million on the HVAC. Turns out, total of 4.15 million, or distributed over the square footage of the building, it's $13.35 per square foot. To illustrate this a little better, we put this in a pie chart, and you can see there's a whole lot of pie and a very, very small slice. This is an added cost of just over 2% of the total development cost. It is real money, but it's compared to the project is very minor. So now we're going to look at the other side of the equation. So those were the extra costs. Where does the money come from? And I call that the reverse piggy bank principle. So you spend the money first, and then you save later. So don't tell your kids that, but that's how a lot of this financing works. And how we determined the incoming savings from the operating costs, we used energy use intensity. That's the measure that I think Rachel earlier mentioned. That is a measure of a building's energy consumption per square foot and year. For some reason, kBTU could be anything, could be kilowatt hours. So this works just fine. For the baseline building, we used EUIs, and we're specifically looking at the site EUI. That's the second to last row here. Site energy use intensities. We got these numbers, 82, from the city. The city benchmarks all, or not all, but over 16,000 multifamily buildings every year. So this is the benchmark number. And for 425 Grand Concourse, we are using a site EUI of 32 derived from an energy analysis by Steve Winter Associates. And because the analyses are based on, ASHRAE and ASTM, whatever it is, they're not, not actuals. We have factored that analysis up by almost a third. That's the margin of difference from typical utility analyses compared with the actuals. That's not a fault of the analysis. They have to compare that apple by apple. This is just a reality of actual consumption. And now, if you know the mix of the various energy sources in the building, and we do know these because these are benchmarked, we know, the distribution between gas and electric fuels, and we have local utility rates that we can apply. So we apply local utility rates. Don't read the fine print. You can take a picture or a screenshot, read it later. In end effect, you are paying $346 for the average new construction building in the city per year, and $1.91 per square foot in year at Grand Concourse. So there's a difference of $1.55 per square foot in year that are actual utility savings that you can harness to pay for these initial expenses. The expenses is $480,000 for the whole building. That's not insignificant, and you can just put that into a calculator. Here, I assumed an interest rate of 6%, changes daily, but you have to assume something. And with these $480,000 per year to pay back the $4.1 million in initial added costs. That's a payoff period of 12 years. Might change slightly. Is it instant? It's not instant. It takes a few years, but it's a very reasonable time frame.